Scaling traditional SQL databases is hard. Managing infrastructure, tuning replicas, and handling failovers can take hours, if not days. But that if your SQL database should scale automatically, handle millions of transactions per second, and require zero manual provisioning. Welcome to Cloudperceptor. In today's video, we are driving deep into Amazon Aurora Serverless with Distributed SQL, a powerful serverless cloud-native relational database that combines the simplicity of SQL with the reliability of NoSQL. Let's jump right in. So before taking a deep dive, let's first understand in a simple terms what Amazon Aurora DSQL is. So Amazon Aurora DSQL stands for Amazon Aurora Distributed SQL. Okay, it's a new type of database from AWS that helps you run one big database across many computers, even across different regions or data centers. Okay, so let's do a simple breakdown here. Uh, Aurora is a fast, fully managed database built by AWS. Okay, and it's kind of distributed, and it is the language that is used to talk to this database is SQL. Okay, so it is scalable, it is global, fast, and reliable. Okay, so with Amazon Aurora Serverless V2, AWS took it to the next level. Okay, showing it to scale compute capacity automatically based on your application's demand. But now with distributed SQL, DSQL, Aurora enables horizontal scaling. Okay, horizontal scaling of SQL workloads by separating compute and storage layers and enabling multi-writer transactions. Okay, this allows multiple distributed compute nodes to handle massive concurrent transactions while maintaining ACID compliance. It's a cloud-native SQL designed for modern, globally scaled applications. Let's go through some of the core features of Aurora DSQL, which is serverless auto-scaling, instantly adjust compute from zero point 0.5 to 128 ACUs based on the load. Distributed transaction execution, multiple nodes can handle different parts of the same transaction in parallel. Decoupled storage and compute. So it computes scales independently while data is centrally stored on a distributed SSD backend layer. Fault tolerance, data is replicated across multiple availability zones with automated failover. Global read replicas, so support for cross-region replication with low latency global reads. MySQL Postgres compatible, easily migrate or plug into existing applications. All right, so just think of it that it is designed for a real-time mission critical applications. So let's understand the architecture of Amazon Aurora DSQL. So just think that your application sends SQL query to Aurora DSQL. Okay, so this is your application sitting in a customer VPC. Okay, uh, there is a distributed query processing layer. So this is the brain of Aurora DSQL. All right. So what really happens here is Aurora breaks your SQL query into smaller tasks. Okay. These tasks are sent to different machines called nodes that may be in different AWS regions. It processes all parts in parallel and returns the results to your app. Okay. So this is a single cluster architecture that I'm showing you, but just think if it is a multi-cluster architecture, then it's going to behave like this. All right. So let's understand the components of this particular brain of Aurora DSQL. So first component is coordinator node, which accepts queries, plan, and coordinates execution. Next comes the worker nodes, where it executes query fragments, scan, joins, and filters. The last one is query compiler and optimizer, which translates SQL into distributed execution plan, right? Next comes the distributed storage layer, where DSQL splits and stores data across multiple nodes. Each piece of data is replicated and fault tolerant. It uses Aurora storage engine underneath, but extended for global use. It is highly available, automatically backed up, and self-healing. So now let's think how it really works in across regions. Okay, so a user in Europe runs a query. The nearest region, Aurora DSQL cluster, will accept the query. The query planner breaks it up and sends part to relevant nodes. Even see, the user is sitting in Europe, right? So even the query planner can break the query down, and some part of the data it can get it from the US location as well. Now the results are combined and sent back to the user. Very fast and convenient. So the key benefits of this architecture is distributed SQL execution, fast even with huge data. Okay. Multi-region reads and writes, which is kind of result in true global access. Strong consistency, there is no stale data. And fault, it is very high fault tolerance. One node can fail, but system will still work. Okay, so just try to draw that 1 second. So this is the multi-region Aurora DSQL cluster that I was just talking before. Okay, so let's first understand the common use cases. Okay, so if you have a high traffic application, let's say e-commerce, fintech, or mobile application that experience sudden traffic spikes, then Aurora DSQL is the best database you can use it for. SaaS platforms, IoT, and event-driven systems where real-time data ingestion and analysis is required, this database is the best fit for that. Database modernization, ideal replacement for legacy RDBMS like Oracle or SQL Server with cloud native needs. Alright, so now we'll head over to the AWS console. We'll have a quick walkthrough of the hands-on demo. Alright, so I'm logged into my AWS console, and I search for Aurora DSQL service. All right, click on that. That's gonna take you to the home page of the service page of Aurora DSQL, where you can find some basic details about Aurora DSQL. There is also getting started links over here on the right hand side. Right. So these are some of the benefits and features which we just talked about. It's virtually unlimited scale, builds app with uh, 99.999% availability, eliminate infrastructure management, and very easy to use. All right. So we are gonna create a new cluster for this. All right. So click on create cluster. For this demo purpose, I'm gonna select a single region out here. Okay. Click on create cluster. So it's very simple to create a cluster. All right. It's going to take a while to create this cluster. Let's wait, have a small coffee break, and come back. All right, great news. The cluster has just got created over here. Just got a green message. It is active. ARN, this ARN public endpoint is also available over here, and the cluster ID. We are gonna open a Cloud Shell over here. Alright, so as you can see, the database just got connected in the Cloud Shell. This is a single region cluster that we just got created. Alright, I'll just create a schema. Create, sorry, schema. Uh, I'll just name it at Cloudperceptor. Right. So show schemas. Right, it's not working. Maybe there is a different command for that. But let's create a quick table. All right, I'll just copy one of the commands from my notepad and paste it over here. Paste, paste. We are going to create a simple table. Okay, one second. I got to okay, let's create a new schema. Example. And now let's create another table in the example schema, right? So here we have created a new table in schema example, all right? We'll create an index over here as well. Create index. So this index also got created. Let's create another table called department. And maybe we'll try to select values from this particular table. Of course, the table is empty. Let's try to run a select query just to see if it is. As you can see, it is not able to find any rows. So let's insert some data in this table and go from there. All right, I'll just insert some values over here, paste and commit. Now let's run the previous query. Okay, we just inserted in the department table, not in the invoice table. All right, I just grabbed the insert query. I will be pasting over here and let's see. All right, there's some issue with the query. Let's try to copy it again. Right, I'm trying it again. Okay, there is some issue with the timestamp, it seems. I'm going to convert it. Right, I'll just paste the query again. What I did is I just added a cast to timestamp. Okay, it is not identifying. Alright, for simplification, what I've done is I've inserted some data in the department table. I'll just select it. Oops. Okay, I think copied a wrong statement out there. 1 second. Alright, so here we have copied the query. As you can see, the select statement is working fine. The data is coming up from the single node cluster, which is this. So as you can see, how easy it is to configure a cluster in Aurora DSQL. Alright, so now let's understand the price and cost optimization of Aurora DSQL. So Aurora DSQL follows pay per second pricing model. You are billed for number of Aurora capacity units, which are called ACUs. So here are some of the optimization tips for Amazon Aurora DSQL. Set minimum and maximum ACUs to control cost. Okay. Enable Hibernate for idle periods. Use provisioned IOPS for only when it is necessary. Tag workloads and monitor with Cost Explorer. So these are some of the optimization tips that I just spoke about. So if you have any regions that are paired to particular cluster, then this pair will show up over here. Alright, since we don't have anything, it's not going to show up. Next is the metrics. So some of the CloudWatch metrics. This is a private link to connect with your using your private DNS endpoint. Okay. You can also create on-demand backup or scheduled backup. This is for the connection. You can get the connection token over here and kind of connect and play around with the database. So this is a basic cluster that we just set it up for Amazon Aurora DSQL. Okay. So uh, so just as a final thoughts, okay, Aurora Distributed SQL is a true next-gen SQL database, blending the ease of relational models with the elasticity of serverless and power of distributed computing. If you're building globally available cloud-native applications and want SQL at scale without the operational overhead, Aurora DSQL is a serious contender. Okay. Try it out, run some benchmarks, and let me know what you think in the comments. And if you want me to compare it with Google, Spanner, Yugabyte DB, and Cockroach DB, hit that like button, okay, and subscribe for more cloud native content. Thanks for watching, and don't forget to subscribe to Cloudperceptor for more deep dives into cloud and AI tools. Drop your questions below. I'll try to answer one of them. See you in the next video.